So the first thing that we're going to cover, I guess, is give you guys kind of a general outline of the topics covered in this webcast. The first thing that you do whenever you do any sort of mold design is do a draft and undercut analysis. A lot of times if you're doing a mold, even if you're the person that's designing the mold, you may not necessarily see it, or you may not necessarily see some of the problematic areas. So using the tools for draft analysis and undercut analysis will help you, even the best mold designer, help you get a handle on what the mold needs to be. The second part of it would be creating your parting lines and surfaces. And there's a lot of different techniques to doing this, but at the end of it all, whenever you're modeling, if you can keep in mind that the core of the mold tools are basically surface cuts and split lines. So if the tools themselves don't necessarily help you, you can always revert back to those fundamental tools and use those to get where you need to be. And then the third part of it is actually doing the tool split and adding things like cores and pins. And then we'll take a look at creating exploded views. Now, with mold design, it's something that's a little bit different than some of the other things that you would do in SOLIDWORKS. Primarily, most of the mold design tools really expect you to be in a single part mode, meaning that you're not going to, while you're creating the mold split, be stepping into an assembly mode at the outset. Everything's built off of a solid part, and then from that point you can get your different solid bodies and then put that out into an assembly so that you can have different materials and part numbers and all this other stuff that you would need for an assembly. But as far as the creation of the bodies, you're going to get the best result if you do it as a multi-body solid, and that's really the way that the tools expect you to work. So let's go ahead and get going into SOLIDWORKS. So I'm going to go ahead and start a new part, and a lot of times if you're working, pardon my split screen, I'm going to be kind of bouncing back and forth a little bit. First thing I want to do is start a new part. A lot of times you can do this stuff within a single part file, but putting your parts into another part helps you kind of separate out what you would need from a design point of view. Sometimes the design is locked or might be used in a larger assembly as far as the production part goes. So if you insert the production part into another part for your mold split, that gives you kind of a control over how the mold changes might propagate out. Sometimes you're going to be doing what-if scenarios with the design, and you don't necessarily want to update your mold. So having that extra layer of having a part within a part helps you control those updates. So in this instance, the part that I'm going to be working with is also an imported part. And I can always go to File, Open up the native part, but you can also go to Insert, Features, and then select Imported. Let me go back to my desktop. So the first thing I'm going to do is bring in this IGES file. So when it does it, whenever you bring in an IGES file or a parasolid or a step file, the first thing it does is that it monitors, or it looks through the part, imports all the different bodies, and then pops it into space. So as with any imported body, it comes into space. Now, in order to analyze these parts or analyze it for for any potential errors, and IGES files are kind of notorious for this, and that's kind of why I chose this file format. An IGES file will basically dissolve the solid body into surfaces, and it's good as a neutral file format because it will open up in nearly any CAD system. The downside to it is that it is at its core a surface model versus a solid, a step in a parasolid would maintain a solid file, whereas an IGES file is really surfaces. So if I right click on the imported body to import diagnostics, you can see faulty faces. It found one. The tendency is to jump in, attempt to heal all, but let's take a look a little bit at some of the more advanced tools. You can repair a face, delete the face, you can recheck it, you can query it as to what's wrong, and you can also zoom to selection. In doing that, it'll kind of flip the part around. You can right click, invert zoom, and again that gives you two different looks, or two different views of how that errant surface is, or the faulty face rather, is in the model. So you can see that, and you can still rotate this around as well. So it looks like at this point I've got a split face, and that's kind of unusual. Quick thing to do is right click, repair face. You could also delete it and manually get into the surface. But I'm just going to select repair because I know that this will actually repair the face without any issues. It tells me that the faces, everything's fine, whatever gaps were there are fixed. So now coming back to the actual mold design itself, let me turn this on. The first tool that you want to use is draft analysis. So if you come over to your mold tools within the command manager, you can see there's a lot of different tools. And again, if you recall at the beginning, I'd said that a lot of the mold tools are basically surface utilities with kind of a scripted menu or some menu assisted guidance. So you can do planar faces, offset. A lot of the surfacing tools are in this. Draft analysis is typically the first thing that you want to do whenever you look at a part for molding. And so the first thing it asks you for is a direction of pull. This is going to essentially be your parting line. So I'm going to select the front face, and you can see that it's got positive draft, requires draft, and negative draft. Some of the things that you can do is adjust this and say, you know, I really want to just look for things that are 2 degrees. So then that kind of adjusts, and we can monitor this here. As you mouse over, I'm not sure how well this is going to show in the web meeting, but as you mouse over each one of the faces, it shows you the draft. If it's something that you're not seeing on your side, a lot of times these types of little pop-up menu items are going to be linked to how well your graphics video driver is performing. So if you're not seeing those things, you might want to take a look at the driver. You can also do an adjustment triad. So the adjustment triad puts in, so triad here on the screen, and I can take my parting line and rotate that. And as I rotate this around to do different ideas about how I might want to split this, you can see that the draft faces update dynamically. So if you've got a problematic face and you say, you know, this thing isn't working out at exactly 90, or you start seeing oddball faces, you can use this triad to rotate the parting line around dynamically to get a different result. If I turn that off, another thing I can do is face classification. If I turn this on, it shows me I can eliminate faces, and this makes things really quick to identify problematic areas. So positive draft, straddle faces, and I think my adjustment triad, let me get back into this. My adjustment triad threw that off a little bit. So front plane, and I'll say 2 degrees. Turn on face classification, there we go. So I can show positive draft, negative draft, and the things that are going to be probably more important from this point of view is things that require draft. So you can see these little undercuts for the tabs are going to be areas that might be problematic from pulling the mold out. So and that's the whole point of doing draft analysis, to find things in your mold that might catch. And sometimes you got to do side cores because it's just the way the part's designed. Other times you can go in and find those things. So we're going to focus on this little area over here. You can see that this fillet right here straddles, it comes down, and because these faces require draft, the fillet on that corner is going to be a problem. So that would be something that would potentially get hung up. So we'll go ahead and jump out of this. Now if I say OK, you can just go back to display. Draft analysis is one of those things that it sticks to the part or stays persistent, so it is a toggle. So if you go to View, Display, and Draft Analysis, you can toggle that off, or sometimes it's helpful while you're editing the part to keep that view persistent on the model. So and that's why it stays there. So I'm going to go ahead and turn off Draft Analysis, and recall that these are the faces that we want to delete. Excuse me. So I'm going to select these fillets. Right click, and then on my faces menu I want to select delete. If I zoom in a little bit, I want to delete and patch. You could just delete and then extend. In a lot of cases, I mean, this part is kind of built to illustrate this, but a lot of times you may not get a clean result, so you would just have to delete extend the faces and then go back in and manually patch that up with some surface modeling. Because that can be a little bit time consuming, and that's kind of beyond the scope of what I wanted to cover. This model does a pretty good job of patching up. So whenever I go ahead and say OK, I'll get a sharp corner, which is what I'm looking for. And then we can go ahead and apply draft. So go into draft. And so Draft Expert, it's a lot like Fillet Expert. And the utility basically allows you to apply draft, look at a model, and then if it needs to resequence features to get what you're asking for, it'll do that. Whereas a manual draft is just very much like a manual fillet. It's going to try to fit it in there without regard to the model history or the feature tree. It's just going to try to put the fillet in, or put the draft in rather, wherever it belongs. So my neutral plane is going to be this top face. And then my face is to draft. Give me that face. This face. And let's see what this does. Now I've got a detailed preview. I can select that, and it kind of washes out a little bit. Let's see. Go ahead and say OK. Now if I go and look normal to this view, you can see my face is draft away, which is exactly what I'm looking for. I can also go back in with Draft Analysis and double check this. Again, selecting the front plane. You can see that that's draft angle is 1 degree, so now if I change my filter over here to be 1 degree, it actually picks it up. Since that's going to be an undercut, we can accept that, but the side faces really is what we were looking for. That we want to do is undercut analysis. Undercut analysis allows us to do just that. Look for undercuts. So we're going to go ahead and select the front plane. You can see where undercuts would be. And again, this has the same thing where I can do undercut faces, hide things that might be undercut, so you can see that over here on these sides we're going to have some undercuts, so that would definitely be candidate for cores, those types of things. Okay. So go ahead and we can do adjustment triad again, very much like the draft analysis where you can rotate this thing around. But pretty much we can see 3 areas where we need to put in some cores and side actions. So I'll cancel out of that. And then the next thing that we need to do is start working on the mold split. So in order to get to that, well, you know what, I didn't put fillets in here. Lost my place. So if I go back in and put some features in, I'm going to put a 0.35mm fillet. In that corner. There we go. So now those fillets are put back in after that face was drafted. So if I look at this part, I would really want to take a look at my parting line. If I rotate this around, you can see that this face would probably be the best candidate because it's a clean split. We probably wouldn't want to have a seam on any other part of the model. It cosmetically would be a good area for it. You know, every job is going to have its own particular areas that lend themselves to a parting line. But if you can have one persistent face rather than having it jog all around, it's going to be a lot easier to machine, a lot easier to handle as far as SOLIDWORKS goes. So we'll go and take a look at the parting line. Go back into our mold tools, and this is one of the areas that SOLIDWORKS really excels in is the user interface and the menu structure. And with a lot of these menu systems that SOLIDWORKS has in the command manager, it definitely leads you left to right is really what we're wanting to do. So first thing we want to do is put in the parting line, shut off faces, parting surfaces. Once the parting surfaces are in place, we can do a tooling split and then a core. So the intent is that we go left to right with these menus. One thing that we should do before we start putting in our parting line is scale the part for shrink. So I can scale that and say we want to make this 2% bigger. We can only scale about a particular object. In this case, I'm just going to select the centroid, but if we did have a particular area where we knew it was going to shrink, we could select that. If I was going to do centroid, say OK. Makes the part just a little bit bigger, and then a lot of times it is helpful just to backtrack it if we put the scale factor in. So we can say scale 2%. That way we can at a glance see what our scale factor is, so if there's ever a question about what the material shrink is, we don't have to go back in and edit the feature and potentially have to have a long rebuild time. We can see it at a glance. So we'll go ahead and do the parting lines, direction of pull, and again this gets back into draft analysis. And the reason that draft analysis is included in this is because it does kind of cast a light over it and it looks for the edge that would most lend itself to that, so to the parting line. So that's good, that's what we want. But now if you look at the menu, it says the parting line is complete. And whenever you see yellow in the menu system with SOLIDWORKS, it's telling you that the command isn't complete yet. So what this is doing behind the scenes is taking your model and looking for a place to split it for positive and negative. So you're going to have the A and B side of your mold, and then what it's going to do is a zero offset on those surfaces. So you're going to end up with a set of surface bodies on either side of your parting line. Those surface bodies can be used to cut as a cutting tool or as an extrude condition, like an in condition for your extrusions. So those types of things are available. That's kind of what it's doing behind the scenes. So we're looking for 1 degree, that's fine. We'll go ahead and say OK. So we have our parting line out there. And then the next thing that we would want to look for is shutoffs. And so if I analyze the model, you can see I've got a shutoff here and then over on this side. So I'm going to go ahead and select shutoff surfaces, or I'm sorry, parting surfaces. Shutoff surfaces. I've got lost my train of thought here. And then if you look at this, you've got these little leaders. It found all the shutoffs that it needs to create on those 2 items all by itself. But if I kind of rotate this around, you can see this one kind of bows out, which isn't really a good machinable. I mean, it may be functional if you could machine something that would really shut off that well, but that's probably not going to be reality. So we can select this. Say it's tangent, and then flip direction. I don't know if that came across, but if I select tangent, so it's going to run tangent to the surfaces that are near it. So I want it to be tangent along that curved face, but then whichever direction I select is going to give me different results. So if the arrow's pointed inward, it doesn't really work too well. So it is one of those visual cues. There really isn't a way over on this side in the command manager to, or in the feature manager rather, to control it. You can see that the face that it gives us doesn't really intersect the part. So what we want to do is flip the direction arrow. Some of the other options on this are going to be all contacts, which is what this is doing over here on the circular edge, is it's looking for all contacts around that circular edge, all tangent, or no fill. Now if you get into a situation where these tools don't, the shutoff surfaces don't work, then what you want to do is you're going to have to manually create those surfaces. But thankfully this part lends itself to that. Now looking again in the message area, it says the mold is separable into core and cavity. So basically I've done everything that I need to do to have the surfaces available for my tooling split. You can see if I expand my surface bodies, you have a folder called cavity surface bodies and one called core surface bodies, and then I have my solid bodies folder. So now if I hide my solid body, and you can see it kind of gives you that gray mottled look whenever you have faces that intersect. I'm going to hide this And so I got a red surface, hide my cavity. So this is really just a zero thickness surface model. Which is exactly what we're after. So one of the tricks that I've learned over the last few years is that if you can't get SOLIDWORKS, if you cannot get these mold tools to work for you, or if it's something that is just, you end up having to do a lot of manual surfacing, what you can do is, so long as any one of the surfaces that you create manually, as long as you put them into these folders, whenever you go to do your tooling split, so it's going to use what's in those folders. So if you need to manually put something in, you're going to end up with some surface bodies below these two folders. Just drag and drop them into the appropriate folder, whichever side of the mold they belong on, and then they'll be candidates for the tooling split and cores and those types of things. So the next thing to do is take a look at our solid, or is our parting surfaces. So I'm going to select that, and this is probably one of the more critical parts of how you do a mold. You can just throw a parting surface out, but a lot of times you're going to end up creating something that is very difficult to machine or costly, or maybe it doesn't shut off well, so you're getting up with flash along the parting line, so then you have lots of post-molding trim operations and those types of things to do. But we'll take a look at some of these settings. So mold parameters, you can do tangent to surface, and you can see that it tries to stay tangent to the existing surface. Do normal to surface, tries to stay as normal to that curve, the parting surface as it can, or you can say perpendicular to pull. And then with that enabled, you can enter a manual mode, which is enabled down here at the bottom. And I can take and pull these triads out. And if I zoom into this area, as I pull this out, I can adjust how that vector, or the edge of that surface, how it gets projected out. And this can be useful if you've got some curvature in the part, and you've got it, you're trying to control how things knit. But there's other ways to do that. So we'll go ahead and cancel out of this and show you a different technique. So I'm going to go ahead and show this guy, and I'm going to hide my surface bodies and kind of come back to the original part file. So what I want to do really is use this surface, and I want that surface to extend out as my parting line. Regardless of the curvature, I want to use that surface. I don't want any interpolation. I don't want it to transition. I just want that to be a smooth surface as it comes out. So if I come back over to my mold tools, I can select knit surface. And what knit surface does is it creates a zero thickness offset for that surface. So now I've got surface knit. If I isolate that, that's all that is. It's just a copy of that surface. Another way to do the same thing would be to do an offset surface with a zero distance. Knit surface just does it in one click is all. So I've got my one surface that I'm interested in working with. I'm going to select that, come back over to my surface tools, and then I'm going to tell it to untrim it. Whenever I untrim, I've got the option I can untrim all the edges, so that means that it's going to, whenever you untrim a surface, it's going to take the edges of the surface and extend them out to their natural edges. Every surface within SOLIDWORKS basically has 4 edges. So whenever you untrim it, it tries to get out to those 4 edges as a matter of, to just create the insert is really where I'm going with this. So I'm going to tell what percent of the untrimmed surface do I want to reveal, and I can say internal edges, which is going to go to the inside, external edges, which is really what I'm after, it's going to go to the outside. I want to make sure that I merge it with the original parting line, and then go ahead and say OK. I'll go ahead and hide this body again. So now what I'm left with is a nice curved surface that is going to be my parting line right through my part. And I don't have to worry about the coming back over to mold tools, the parting surface creating an extra surface that's trying to blend in with the existing thing that I'm doing. This is just basically a copy of the existing surface, untrimmed with SOLIDWORKS tools, staying as native as possible. It's going to give me the cleanest parting line. So I'm going to go ahead and create some sketches for my insert. So I'm going to go to my front plane, which is my parted line. And I'm going to create a rectangle. I'll go ahead and switch this to metric just to make it a little bit cleaner. Excuse me. So that's my insert profile. So I'm going to name this sketch just for clarity. That's the shape of my insert. And then what I want to do is come up with a surface that's basically going to trim against this. So I don't want this tail back here, and I do want it to blend in nice, excuse me, nicely with a clean edge. So I want this to be straight. Let me kind of rotate this around. I want it to come straight in and then follow the width of this part. So what I'm going to do is create another sketch on my front plane. I want it to be 37 millimeters off of that edge, off the top edge. Pull this in a little bit, maybe 23 off the front edge. Then I'll add a 30 millimeter fillet. And then I'm going to call this my trim profile. So hopefully you guys are following what's going along. So the next thing I want to do is take this trim tool and trim this surface out for myself. So I'm going to come back to my surfaces, trim surface with that tool. And what I want to keep, so I got keep selections, remove selections. So I want to keep the inside. So now I've got a nice clean surface. So now at this point what I want to do is insert my mold folders. So coming back to my mold tools, insert mold folders, and notice it came up with cavity, core, parting surfaces. So I can take this, drag this up into my parting surfaces, and now I've got pretty much a clean shot. Hide this guy. Everything that I need, should need anyway, to do a tool split. So now if I select tooling split, select my profile, everything that it found in those folders, and I don't mean to be redundant, but I just want to make it clear because this can really help you out if you need to manually do these types of splits. You got core cavities, so that's a nice core surface, cavity to cavity, parting surface to parting surface. So for the top one, I want to say maybe 37 millimeters. Now there is an ability to add interlocks, depending on what your molding standard is and how you guys, how you may want to do this. A lot of places will not put in the interlocks at the parting line. They'll actually add them on the outside of the mold, but if you're in the habit of putting them on the parting line, you can do that. So I select the interlock faces. I want a 3-degree interlock. Okay, there we go. One of the things that we can do, let me turn on my edges so you guys can see the parting line. One of the things that we can do in SOLIDWORKS 2012 is with multi-body parts, we can do exploded views. So if I come over to my configuration tab, select my default configuration, create a new exploded view, I can select this part, move it up, and then I can say OK. So now I've got, let me hide my surface bodies. You can see my inserts, my A and B side. Are there any questions on that so far? Okay. So now the next thing we want to take a look at is the cores. So if I look at this, we've got some side actions in here that are going to be required, and I'll go ahead and cover this real quick because it looks like we're running out of time here pretty fast. So what I want to do is, in order to split out these areas, and again keep in mind that I'm in a single part file, I'm going to go ahead and hide this part, and what we're going to do is create a split line that basically trims out this part into a separate body. So I'm going to create a sketch, create a plane rather. One of the things that you'll notice about exploded views is notice how my menu is all grayed out. Wait for this rebuild to finish. So in 2012, the new exploded view, whenever that's active, it prohibits you from creating any other views. So I'm going to go ahead, collapse that, and now my tools edit, or my tools light back up. So if you are creating exploded views, remember to collapse it before you can edit it again. So I'm going to create some reference geometry. Second reference point is going to be the midpoint of that edge. So you can see that it's intersecting both of those items. It tells me it's fully defined. I'm going to create a sketch on that face. Now if I switch to a hidden line visible, I can see kind of inside of my part. So what I want to do is create a side core. Spin this around, holding my Alt and arrow keys to just kind of spin that around a little bit. What I want to do is pull this back, and then I want to, instead of using this line, I want to take the edge of this entity, convert entities. Convert entities takes that sketch, pulls it forward. Exit out of convert entities, pull this up just a little bit. Left down. So for this side action, I'm going to make this maybe a 2 degree. Come up 3 degrees or 3 millimeters off that edge. And the whole point is to, if you look at this, I'm shooting a little bit high above that slot. So the exact distance really isn't as important as to make sure that I'm including the geometry in my split that I want to include. And then we'll say from here to there be 35 millimeters. Since I want to do it on both sides and I don't want to have to sketch it again, I can still create a center line. Select my chain and my center line and tell it that I want to mirror them. So now I've got the same thing on the other side. So now coming back to my mold tools, I can use those sketches as a core, or use those sketches for my core tool. And the core is essentially it's just like doing a split line. Some of the other tools that would be equivalent functionality would be doing a split, and that's effectively what it's doing. It's just with some special utilities as far as how to select it in regards to the mold. But really what you're doing behind the scenes is creating a split feature. So now going back to my shaded view, I'll hide this. Come back over to my exploded view. Now if I edit my exploded view, I can take this, pull it out, this. And you can see on the inside I've actually got those pass-throughs on the side cores. So now using the tool, basically it's just splitting it out. You create a sketch, tell it how far you want to offset on either side, and that's pretty much it. So looks like we're about running out of time, so if you guys if you don't have any questions, or if you want to see something again, go ahead and let me know. If I wanted to split this out, and this would be really the final step for mold design, you know, I would go through and put ejector pins and that kind of stuff in. But what I can do at this point, say that this is going to be my core, right click into this, collapse this first, right click on it, insert in a new part, and then that gives me, I'll call this bezel core, or cavity, whichever side. So now looking at the feature, I've got a dash greater than symbol, so that's telling me that this is in context. At this point now I could go through on this particular part, because I typically wouldn't want, I want to do I would want to create a print of just this insert apart from the other components. So at this point I could come in with my whole wizard, create water lines, I want to make these a little bit lower. So got water lines coming through here, and then maybe put them on the back side of this as well. So now I could just do a print of that particular component and continue on with typical modeling techniques. But the point is that you would want to have your stock, everything linked back to that original split part file, and then have these components with the mounting holes, water lines, all this other stuff in separate part files so that you can do prints, assign part numbers, have different materials, make it a lot easier to manage versus trying to keep everything in a single part file. The SOLIDWORKS approach to mold is pretty, it's very much single part file centric, if that makes sense or if that's a word, but that's really going to help you out if you kind of get, adopt that practice. Thanks for attending. If you guys have any questions, go ahead and email us or give us a call. I'll go ahead and conclude the webinar unless you guys have any questions.